Hi, this is Dr. John Bergduff. This video is about effective annual yield, which is actually a subtopic of the topic compound interest. The meaning of effective annual yield is the simple interest rate that would generate for you the same earnings in 1 year as the compound interest rate that you are considering. Simple interest rate is simply interest equals principal times rate times time. So that's not a terribly beneficial way of earning income. However, it does provide a way to compare two offerings of compound interest to decide in a year which one would give you the best earnings. In this example, and there are actually two examples here to look at that are similar but slightly different, and I'm asking you for the effective annual yield in each case. In the first example, we're looking at a savings account that earns a nominal rate, that's a stated rate of 6.29% compounded quarterly. In the second example, we're looking at a savings account earning a nominal rate of 6.25% compounded daily. Purpose of this formula is fairly clear in looking at these. In example 2, you have a lower interest rate. So you would think, well, that's probably not going to get me as much money. However, the compounding period is more frequent, and that might make up for it. So we need an apples to apples comparison system that would enable us to know which one of these two is best. And calculating effective annual yield is a way to do that. Again, it will calculate for us what is the simple interest rate that would generate the same earnings for us in 1 year as the given compound interest rate. There is a fairly simple formula, and I'm going to show you how to calculate using that formula using a TI-84 graphing calculator. The unknowns are R, N, and T. R is the nominal annual rate. So if I start in example 1, the nominal annual rate is 6.29%. That has to be converted to a decimal, 0.629. Zero, there we go, 0.0629. Otherwise, it would have been 62.9% interest, and that would be pretty phenomenal. N is the number of compounding periods per year. If we're compounding quarterly, that would be 4. Y is what we're trying to figure out. We're going to plug all that into our graphing calculator, and we get to enter it exactly the way it looks. First, we see parentheses. So we would say 1 plus, and then the interest rate, 0.0629 divided by 4, close off the parentheses, raise that to a power. This is the button, the one that looks like a little hat, actually called a caret, allows you to raise a quantity to an exponent. On a newer graphing calculator, the cursor will move up into an exponent. In the older versions, it does not. In older versions, you actually need to put parentheses around the exponent. I generally think that's a good idea. However, since this exponent only is going to have one quantity in it, I don't think it's necessary. Now, if I hit -1 right now, that subtracting of 1 will stay up in the exponent and really mean that I'm looking at an exponent of 3, and that's not what I want. I need to get out of the exponent. Among these buttons here that are sort of forming a wheel, if you just click the right arrow option, it'll get you out of the exponent, and you can hit then -1 and enter, and you will get the effective annual yield, also known as the effective rate. For my answer, I'd like to express that as a percent. So I'm going to come back over here, and I think I'll write that as a percent to 2 decimal places, 6.44% when it is rounded off. And I'll just leave it on the screen. For comparison, the second example, the interest rate is different. It's 0.0625. And because we're compounding daily, our n will be different. I'm going to use the banker's rule, which says that a year consists of 360 days rather than the traditional 365. That is generally what is used in most financial calculations. It's called the banker's rule. Otherwise, this is entered the same way, open parentheses, 1 plus the new interest rate, 0.0625, divided by n, the number of compounding periods, that's 360 in this case, raised to the power 360, that's my n again. Push the right arrow on the little wheel to get out of the exponent, minus 1. And I'm going to round that off to the 2 decimal places again. Notice that rounding to 2 decimal places means we'd be looking at this 8, and this should be rounding to 6.45%. Now we can really make a comparison. Obviously, incredibly close numbers, 6.44% effective annual yield in example 1, 6.45% in example 2. As it turns out, even though the nominal interest rate was lower, the compounding more frequently made a difference. And although it's not a huge difference, example 2 is a slightly better deal for us. Thanks very much.